Okay, hey everybody. Sorry I'm not here today. I have a sick child at home. But if you were involved in the musical last night, you all did an excellent job. I came to watch it and you were fantastic. So nicely done. All right, so now let's talk about some more circle stuff. So this first part, name the circle, name 4 radii. I would like you to do all of this, but you're just going to do it after you watch the rest of this video. So we're going to skip past it for now, but I want you to come back and do it because naming things and knowing where they are is extremely important in this unit. But I'm going to jump down here to do the stuff that you don't know how to do yet and start here. What's common about each group of circles? Well, if you look at it, I mean, you should see some similarities and differences between the two groups. But basically, what you should notice in this group is that all of these lines touch at one point and only one point, whereas these lines pierce through the circle. So you already know what a tangent is. A tangent is a line that intersects a circle exactly one time. And I spelled exact. That should be a T, and I don't need that. A line that intersects a circle exactly one time. A secant is a line that intersects a circle twice. So a tangent line balances on the circle, a secant line pierces through the circle. Okay, so tangent, secant, there you go. So there's this construction here. Basically, use a compass and a straight edge and construct the line perpendicular to the tangent. Just to save time, because this is a video here, we're not going to construct it. We're just going to draw it. If I want to find something that's perpendicular to the tangent, you should remember from a little while ago that a radius is perpendicular to a tangent. So tangents and radii are perpendicular, okay? All right, now it says, what if the tangent line doesn't intersect the radius or the diameter? So if it's perpendicular to the radius, which would therefore be perpendicular to the diameter, what if it's a tangent and a chord, okay, like we have over here? So if we have a tangent and a chord, those aren't perpendicular, so we need to figure out what we do with it. So why is Tn tangent to the circle? And we're going to say because it only touches once. What type of segment is AG? I just said it before. AG is a chord. All right, now we get into a little bit more details. What is the intercepted arc for angle TAG? So TAG is this guy right here, and TAG is eating arc AG. So I don't know if you can see it, but TAG is eating this piece. So the intercepted arc is arc TG. And since arc TG is actually more than 180, to be a little bit more specific here, did I say TG? I meant AG. But to be a little bit more specific, arc AG is more than 180, so I'm just going to stick an extra X there and call it AXG. All right. And then what's the intercepted arc for NAG? So NAG is the other side. That's intercepting smaller arc AG. So NAG is intercepting this arc over here. Okay. What types of angles are TAG and NAG? How do they compare to each other? Well, TAG and NAG, you might want to call them inscribed, but technically they're not because they're not formed by chords. This is an angle formed by a tangent and a chord. So we don't get to call them inscribed, but they are on the edge of the circle. So when we say what type of angles are they, I'd like you to notice that they are a linear pair. And since they both make a straight line, they are therefore supplementary. All right. So those two angles add up to 180 because they're supplementary. And then it says, what do the arcs add up to? So what do arcs big AG and small AG add up to? Well, that's the whole circle. So big AG and small AG add up to 360. Now notice our angles added up to 180 while the arcs added up to 360. So the rule is this angle right here is half of the arc. Okay, so how do the sums compare to the sum of the intercepted arcs? It's half. So if the measure arc of AG is 200, so if I kind of just sketch this back here for half a second, if this is 200, therefore this angle would be 100. So that would be angle TAG has the measure of 100 and the measure of NAG. So if this is 200, this would have to be 160, and half of 160 would be 80. Okay, so the rule you just learned is if you have an angle formed by a tangent and a chord, the angle is half of the intercepted arc. So it acts like an inscribed angle, it's just technically not an inscribed angle. Okay, how am I doing on time? It's been 6 minutes. We are cruising. Turn the page. More rules here. So if we come back here, whoops, went too far. If we have angles formed by tangents whose vertex is on the circle, there's technically 2 rules, one of which you already know. The measure of an angle formed by a line tangent to the circle and a radius is 90 degrees, which means OP would be perpendicular to AB. And the measure of an angle formed by a tangent and a chord is half the intercepted arc, which means X is half of Y. So if we come down here, do a couple examples. What's the difference between the locations of the angles in the diagram shown below? Well, this one's on the inside, and that one's on the outside. How many intercepted arcs on the interior of the angle in figure 1? Okay, so here's a trickier question. Inside here, we've got this little angle that is eating this arc. There's only one. But when I have an angle outside, there's 2 arcs. There's this guy that's almost swallowed, and there's that guy being eaten by the arc on the outside. Okay, so there's 2. How would I find the measure of the angle in figure 1? The arc is 2 times the angle, or the angle is 1/2 the arc, depending on how you look at it. So the rule here is when you only have 1 arc, you take half of it. But what would I do with 2 arcs? I can't take like half of each of them. I mean, that's a little weird. So we do a little something different over here. If you have an angle whose vertex is on the outside of the circle, the measure is half of something, but it's half of the difference of the measure of the intercepted arcs. So this angle one out here, you do x minus y and then subtract. You do x minus y, subtract, and then divide by 2. Same thing here. This was formed by 2 secants. This is formed by a tangent in a secant, but if you look at it, this mouth is still eating 2 things. So I do x minus y and then divide by 2. And even on this one where it's formed by 2 tangents, if I have 2 tangents, I do x minus y divided by 2. Okay? All right. ACD. ACD is formed by which 2 types of segments? All right. AC touches the circle twice. That is a secant. CD touches the circle once. That is a tangent. Fantastic. All right. What is the measure of arc AD? Well, they gave me this as 100, and they gave me that's 85, and this is all that's left over. And all the way around the circle should be 360, so this is 360 minus 185, which is going to be 175, and that's what's here. Therefore, the measure of angle ACD, well, ACD is eating this and that, so I'm going to do 175 minus 85 and then divide by 2. 175 minus 85, I believe, is 90. Divided by 2 is 45. Okay. Number 2, angle ARC is on the edge of the circle, and it's formed by a tangent and a chord, and the rule is the angle is half the arc. So if this angle was 70, the arc would be twice that, which is 140. Y is outside the circle. In number 3, if the angle is outside the circle, it's the difference divided by 2. 110 minus 30 divided by 2. 80 divided by 2, which is 40. Find the value of W. Okay, well, this is 2 tangents. This guy's 70. 70 should be 1/2 the difference of W and 110. So what I could do is I could write an equation that said 70 equals W minus 110 over 2. And then if I wanted, I can cross multiply. 70 times 2 is 140 equals W minus 110. And then I'm going to add 110 and get W equals 250 and get the answer. And maybe there's somebody in the audience right now who's going, Mrs. Weber, did you really need to do all that? No, I did not. Because if anybody's noticing, this 110 is one side of the circle. This is the other side of the circle. So for W, I could have just done 360 minus 110 and gotten 250 as well. Either way works. Okie dokie. Pardon me, I'm going to blow my nose, so I'm sorry if you hear it. Okay, I'm back. Ready? Here's another one, but I'm going to give you an easier rule now. For this guy, I don't have a single arc. All I know is this is 35. Ready? If you have an angle outside a circle and it's formed by 2 tangents, what you can do is you can say, well, you know what? I'm going to put a radius right here, and that's going to be 90. And I'm going to put a radius right here, and that's going to be 90, right? So those 2 things are 90. This is 35, and I don't know if you remember this, but if you have 4 angles inside a quadrilateral, they all add to 360. So 35 plus 90 plus 90 plus, I'm going to call this y, is 360. So 90 plus 90 is 180, plus 35 is 215. 215 plus y is 360. If I subtract 215, I'm going to get y equals, what? 145. 145, that sounds right to me. So if this central angle is 145, then this arc is equal to that angle. So x is 145 as well. And even better than that, this leads to one more rule, and that rule is the following. If you have a snow cone, meaning you have an angle formed by 2 tangents, can you guys see how this looks like a snow cone? If you have a snow cone, the angle and the smaller arc, these guys will always add to 180. 35 plus 145 is 180. So you can either solve these equations like what we just did, where you draw in the 2 radii, or if you want, you can just remember that if it's 2 tangents, only 2 tangents, these guys add up to 180. Okay? And then last but not least, down here on number 6, because I think your homework's right after this, if we look down here at number 6, angle A is an inscribed angle, so it's half of the intercepted arc. So A intercepts 100, so A is half of that, making it 50. B is an intercepted arc. It's eating 110, so half of 110 is 55. C is an exterior angle of the triangle, and here's a rule we haven't used in a while. The exterior angle of a triangle is equal to the sum of the 2 remote interiors. This was 50, this was 55, so C is 50 plus 55, which is 105. However, also not the only way to do it. You could say, well, 50 plus 55 is 105, making this 75. 75 plus C is 180. also making C105. Okay, so I'm going to end with a terrible sequence of jokes, but you're going to giggle a little bit, or maybe you're not going to giggle and say, oh my god, why did I end up with Mrs. Bibber? Here they are. Why does an elephant paint its toenails red? So it can hide in cherry trees. Well, wait, why do elephants hide in cherry trees? So they can jump out and scare people. How did Tarzan die? He was picking cherries. All right, everybody, have a great day. Do your problem set for homework. Don't forget you have a weekly due Wednesday and corrections due next Wednesday as well. See you later. Have a good weekend. Bye.